Welcome to your next quest. In this quest, we're going to want to add some things to our effect context. You see, in the exec.calc, we've determined whether we got a successful debuff. But now we need to get that information on through. I'd like to send that info through to the attribute set in the effect context. So for your quest, I'd like you to add some variables to the effect context. We want to know whether or not it was a successful debuff by the time we hit the attribute set. So add a boolean for a successful debuff, call it b is successful debuff, and add some floats as well. We need to send the debuff damage, as well as the debuff duration and the debuff frequency. Now, if you'd like a bonus, see if you can send the damage type as well. So add that to the effect context if you want an extra challenge. Now, the damage type is going to be trickier because these variables need to be serialized. They need to be added to net serialize, right? So that's part of your challenge, not just adding these variables, but taking care of serializing them, as well as adding getters and setters for them. And if you want to take it above and beyond, add functions in Aura Ability System library for getting and setting them. So damage type is an fGameplay tag. That's more complicated than serializing a boolean or a float. So if you feel like that extra challenge, add the damage type. And I'll give you a hint for the damage type. If you don't want to hear that, pause the video now. But if you want the hint, here it is. Take a look at how a hit result is serialized. So pause the video and conquer this quest now. So our challenge is to add some more variables to our custom effect context class. So I'm going to close all my tabs and open Aura Ability Types.h. And we're going to add some more variables here. So down in the protected section, they can come in down here. I'm going to add a new boolean called b is successful debuff. And it'll be set to false by default. And it needs to be a boolean. Now, in addition to this boolean, we need some floats. I need a float called debuff damage. It'll be 0 by default. I need a float called debuff duration. That'll be 0 by default. And I need a float called debuff frequency. That'll be 0 by default as well. And I'll put uProperty macros on every single one of these. So that's step 1. If only this challenge were that easy. Step 2 is making sure that these are serialized. That's step 2. So we can break step 2 down into substeps. First, we need to look at Aura Ability Types.cpp and see how we're serializing everything else. If we're saving, then we're flipping bits, and we're kind of going in order here. The order sort of matters, right? And at the very end, we're flipping bits 7 and 8 for B is blocked hit and B is critical hit. We're going to flip more bits now. We need to flip a bit to represent whether or not we should serialize B is successful debuff. And we should only flip it if B is successful debuff is true. Otherwise, we can save on some bandwidth. So I'm going to place an if and say if B is successful debuff, then we'll flip the next bit. So we're going to take rep bits. We're going to use a bitwise or equals, and we'll use 1 left shift 9. So only if it's a successful debuff, we'll flip that 9th bit. We can use the same optimization techniques for the debuff variables. If they're 0, there's no point in replicating. So we can flip bits 10, 11, and 12 only if these are non-zero. In fact, if they're greater than 0. It doesn't make sense for debuff damage, duration, or frequency to be negative. So I'm going to check if debuff, and I want to go in order, debuff damage is greater than 0. Then I'll go ahead and flip the next bit. I'll just copy this and paste it, but we're going to flip bit number 10. Next, we need debuff duration and frequency. So I'm going to take the if statement, copy, paste it, and change this to debuff duration. and we'll flip bit 11 for that. And then one more time, copy paste. This will be debuff frequency. And we'll flip the next bit, which is bit 12. So that takes care of flipping the bits. After that, we have the serialization part, the archiving into our F archive. So we're going to go all the way down to after we've archived B is critical hit, and we're going to archive the next one. So first we check to see if the next bit has been flipped. That's 9. And then we archive B is successful debuff. That one was pretty easy. Next, we check to see if the 10th bit has been flipped. If so, we archive our debuff damage. We have to go in order. It doesn't have to be in the same order as the variables are declared. It has to be in the same order that we flipped the bits up here, because those bits represent these variables. So it's debuff damage, duration, and then frequency. So here we got debuff damage. Next, we're going to check the 11th bit. So change this to an 11, and this will be debuff duration. And the frequency is last. So we're going to get the if statement, copy it, change this to the 12th bit, and this will be debuff frequency. And there we go. We now have taken care of serialization for our 4 new variables. And we can add getters and setters, but before we do that, I'm going to tackle the bonus challenge, serialize the gameplay tag for damage type. Now this one is a little bit more complicated, but nothing we can't handle. We can just take a look at how we did it for the F hit result. And as you can see, the F hit result here on our custom effect context is a protected member variable, which is a T shared pointer. It's a smart pointer. So this is one of those few cases where you'll see a hit result stored as a pointer. The member on the effect context is a shared pointer. So that's what we're going to have in our ability types. So we're going to have a T shared pointer of type F gameplay tag. Instead of hit result, we're going to call it damage type. Now we don't give this a U property. It's a shared pointer. Garbage collection is not handled for shared pointers by U property. The shared pointer and other associated smart pointers handles the automatic memory management. So now that we have a F gameplay tag, let's take a look first at way up here where we have our hit result. We're just checking to see if it's a valid hit result before flipping the bit. We're going to do that here. So we're going to say if, and we're going to use damage type dot is valid. If it's a valid pointer, then we'll flip bit 13. And then down here, we can see what's going on for the hit result. If that bit has been flipped, we do something if we're loading. If we're in the loading mode, then think about this. We're not saving, we're loading, which means the hit result has already been serialized, otherwise we wouldn't be inside this if statement, and we're about to unserialize it. So what we do is check if that hit result pointer is valid. If it's not, then we create a new one. We dynamically allocate a completely new shared pointer for the hit result because there doesn't exist one yet. After that, we can take that hit result and call net serialize on it. And that takes care of the archive business, right? It's like doing this for all types that archive has overloaded the left shift operator for. Archive doesn't have the left shift operator overloaded for hit results, but hit results can handle it. It takes the archive, the map, and the Boolean in as input parameters. We're going to follow this same pattern for our gameplay tag. So we can copy this whole if statement. And all the way down at the end, we're going to check to see if that 13th bit has been flipped. And we're going to also see if the archive is loading. And then we'll check our damage type. We're going to say if damage type dot is valid. If it's not, notice the negation operator. Then we create a new damage type in a shared pointer of type F gameplay tag. And we create dynamically a new fGameplay tag in this shared pointer. And by the way, Writer says you can make this with make shared if you wanted to do that. Now, after we've created that new shared pointer and assigned it to damage type, if we're in the loading mode, then we take damage type and net serialize. We do that whether we're saving or loading, but if we're loading, we had to create a new one. Okay, so now that we're serializing these based on rep bits, it's very important that we come back up to ar.serializeBits because we're now serializing more than just 9. Before we were serializing 9 of those bits. Now we have 4 more. So now that it's a total of 13, we have to pass that into serialized bits. So this will now be a 13. All right. So now we've handled net serialize for our damage type gameplay tag. And the last thing to do, at least in this struct, is to create some setters and getter functions in Aura ability types.h. So we'll go up here and we'll have setters and getters for each of our new variables. So first, the getters. We're going to make a bool called is successful debuff. It'll be const and return that boolean, b is successful debuff. Simple enough. We'll also have a float returning function called get debuff damage const, and it'll return debuff damage. Let's make a float called get debuff duration, which is const and returns debuff duration. We'll have a float called get debuff frequency, const return debuff frequency, and we'll have a function that returns a t shared pointer of type fGameplay tag called get damage type. This will be const and will return damage type. So there's our new getters. We need setters as well. So we're going to have void set is successful debuff. Which will take in a bool called b in is debuff. We'll just call it that. And we'll set b is successful debuff equal to b in is debuff. We'll have a void function called set debuff damage, which takes a float called in damage and sets debuff damage to in damage. We'll have a void function set debuff duration, which takes a float called in duration and sets debuff duration. Equal to in duration. We'll have a void set debuff frequency, taking in a float in frequency and setting debuff frequency to in frequency. So with that, we have setters and getters, and perhaps the last step of all this is to add some functions to our Aura ability system library that can set these by taking in input parameters, including a gameplay effect context. So we'll go ahead and open up Aura ability system library, and all the way up at the top is where I'm interested because we have a couple of functions. Actually, it's not exactly at the top. We have is blocked hit, is critical hit, and so on. I'm going to make getters that take in effect context handles that correspond to my getters here is successful debuff, get debuff damage, and so on. So I'm going to take is blocked hit, I'm going to copy it and paste it, and I'll have a static bool that is called is successful debuff. And it can have all the same stuff. Same category, blueprint pure, all of that. I'll also declare a new function that returns a float. And this will be called get debuff damage. And I'll make 3 more functions that return a float that get the other debuff parameters. Get debuff duration, get debuff frequency. And I think, is that it? Okay, that's all of the debuff functions. The last one would be get damage type. I'd like get damage type to just return a gameplay tag for me. So I'm going to go ahead and make another function, but this will just return a fGameplay tag. We'll handle all the pointer business in the function to make it easy. So this will be get damage type. Okay, so we have a number of new functions, 5 to be exact. Let's highlight them all and generate definitions for all of them. Now, these are going to be similar to their counterparts, like is blocked hit, for example. We're going to get our aura effect context, use a static cast to f-aura gameplay effect context, and then return the value that we retrieve from the getter function on the aura effect context. So really, I can just copy that, paste it over here, and call is successful debuff. We'll do something similar for get debuff damage. The difference here is we're going to have to call get debuff damage, and if this if fails, we have to return a float, so it's got to be 0. So I'll copy this, we'll paste it in get debuff duration, only we're calling get debuff duration, and we'll paste it in get debuff frequency, only we're calling get debuff frequency. Now, the gameplay tag situation is a little bit different, so how are we going to handle that? Well, let's start by copy pasting, and what we return down here would be an fGameplay tag, right? An empty one. But here is where we're going to do something a little different. What we have to do is check if we take the aura effect context, we get damage type, what we call is valid on it. Gotta be valid. And if it is valid, then it's safe to dereference that pointer. So we say return and we dereference aura effect context, get damage type. That way we safely dereference, and if we get to the end, we return an empty gameplay tag. Okay, let's go ahead and compile and make sure that we haven't made any mistakes. And with that, we have a successful compile, and we now have some easy to use ability system library functions that we can pass in an effect context handle to set these parameters. We know that our effect context in aura ability types has some additional parameters, in particular ones related to debuff, and it also knows its own damage type. This is going to be really useful because we can pass that info along in the effect context and use it later in the damage pipeline. Excellent job. We'll continue with this in the next video.